Welcome to Alyvix. Today we'll explore a real-world case where an IT company uses Alyvix to visually monitor a production environment email server that the entire company depends on every single day. Let's get started. Hi, I'm Charles, technical writer here at Alyvix, with an important question for you. Who wouldn't like their application performance to remain stable under load? If you have a large number of users dependent on network-based applications, such as Microsoft's Outlook, what will happen when those apps start slowing down? All those users would immediately start being less productive, which means your organization will be losing money. Applications like Outlook and Exchange Server are network-centric, so any services they run can be slowed down or even blocked by problems with the intermediate network or with remote servers. When the experience your end users have degrades, problems will grow more and more costly. You need a way to find out when your users are having trouble with their applications before they become full-blown problems, so you can begin to do something about it. The simplest way to check would be to assign someone to try every aspect of each application, clicking on interfaces to reproduce his or her coworkers' tasks all day, every day. Let's call her Carol. There she is. Needless to say, this would be expensive, really boring for poor Carol, and a waste of resources. There's a different approach, though, that doesn't have these drawbacks. This approach is to use automated assessment, replacing the eyes and hands of the human tester with software that can continuously and tirelessly perform, measure, and report each individual step in all these workflows. Let's get more specific and look at a real-world example where this automated approach is currently used to assess the application performance of the widely used Outlook email client. Consider an IT company that uses Outlook to coordinate all its internal communications and calendars. These IT systems are the link between its own employees and between employees and customers. Any downtime can result in missed connections and general chaos within a company. It's vital to restore service as soon as possible to keep the company moving forward. To keep critical applications like this running smoothly, an automatic approach will regularly step through the most important tasks that Outlook users carry out, like reading and sending email, and making calendar appointments in order to check the stability of Outlook's end-user experience. Visual monitoring is the name of this automated approach that reproduces end-user task steps by clicking on the same buttons and typing into the same text fields that users do. At each step, when the GUI responds, the elapsed time between the action and the GUI response is recorded. This approach is specially suited to streamed and closed-source applications like Outlook Web Access because it doesn't require programmatic access, just the standard user interface. So for instance, in daily Outlook usage, an end-user task like checking incoming email, as shown here, would include a step to click on the New Email button, and then to type in the addressee. Then the elapsed time is from when the addressee is entered until when Outlook confirms the addressee is valid. Alyvix is a visual monitoring system for any Windows application, including Outlook. Alyvix has tools for creating scripts that replicate end-user workflows, and then automatically running them at regular intervals, recording how long an end user would have to wait for each step in the script. It also creates reports that can certify application performance to third parties. On an important business task like scheduling customer appointments, you use Alyvix to define each step within the calendar interface, then rerun those steps with an Alyvix bot, which uses Outlook and its application interfaces as if it were a real user. So what does it look like when Alyvix runs a bot on an interface like Outlook Web Access? Just like a person, it logs in, clicks on buttons or controls, types text in fields and boxes, and then logs out. After each interaction with the interface, it records how much time was needed for the application to respond with the next stage of the interface, and captures a screenshot. The robot runs like this automatically, repeating the same test each time at the interval you set. You can visualize the timing data from these runs in a stacked dot chart, where each point represents one step of one specific run, and where the distance from one dot to the next higher dot corresponds to the amount of time that UI step took to complete. When a second run is executed, the timing data for its steps is also recorded. As the bot runs more and more task workflows, you can see both the recent workflow performance to find out if the application is slow or not, and also compare it to prior performance results to see how performance is trending over time. In fact, once you've run the workflows long enough, you can visually inspect the continuously recorded data to quickly note when the application was down, see whether the user experience is improving or degrading over time, and even gather data to help you decide proactively how to optimize system resources, allowing you to save money by using the least amount of resources necessary to maintain your user experience standards. When looking for the causes of problems, it's extremely helpful to be able to interactively visualize historic application performance data. Here's 3 months' worth of data from a real-world Outlook application in 2 interactive graphs. The overview graph on top combines latency and availability, where each column represents the cumulative speed of a particular work task run every 4 minutes, while the graph below shows individual step completion times of that task with a different color for each separate step. When the company's IT department sees a stretch of high values in the upper graph corresponding to application response times exceeding the desired standard, system admins can drill down to the exact time period when those values began to occur in order to find the root cause. For instance, if a bot running an email client task flow makes a database request as part of its interaction sequence, and the database at that moment is slow because of networking issues, then the specific task step using the database will be immediately visible in the graph just due to its color. If instead the timing results are significantly high, setting alerts or notifications allows you to intervene immediately when users begin experiencing problems, even if they don't show up yet on other monitored objective metrics like disk space or VM availability. Expanding the performance graph below and zooming in to the measurements of individual steps allows you to pinpoint which transitions slow down and when. You can see when daily performance peaks occur so you can plan ahead, and you can even see when administrator interventions return applications to their expected performance. The reports that Alyvix server produces can serve as permanent records which can certify actual availability and performance over time. They show the total amount of time taken, whether the run as a whole was successful or not, and provide detail on the individual steps. For each step, the report shows its individual timing measurements and screenshots, indicating what was seen at each moment. In particular, it shows what the end user would have experienced when an application was suffering slowdowns or not working at all. If the IT company used Outlook as a remote service under a service level agreement, a report with timing details and screenshots can serve as proof that the SLA was being breached. As a visual monitoring system, Alyvix navigates through remote applications like Outlook, executing tasks using the same graphical interface that an end user does. As each task is performed, Alyvix automatically and continuously assesses application responsiveness, recording the time required for each transition in the workflow and saving screenshots for use in later troubleshooting. Alyvix is the right tool for visual monitoring, providing everything you need to monitor your networked and cloud applications. Beyond increases in productivity and profitability because your end users won't have to wait to finish their work, Alyvix can also help you optimize your infrastructure by seeing slowdown trends, test changes to interfaces in real time, retain multi-tenant customers who depend on your infrastructure, and allow you to audit your SLAs. No more excuses like they said response time was under a second. You'll have proof it was significantly worse. Thanks for watching this Alyvix video. Be sure to check out the Alyvix server website, blog, and user guide at these links. And don't forget, you can also like, comment on, and subscribe to our YouTube channel to be notified about new videos.